we will be solving linear systems in 3 variables. In our example, in our notes, we did these 3 equations in order to demonstrate solving a 3-variable system. I would say that the biggest thing in choosing what to do in step 1, we want to substitute or eliminate, use substitution or use elimination method to write the system of 3 variables to a system of 2 variables. We need to decide which variable we want to get rid of. And in doing that, we want to choose a variable that maybe already cancels right away, or maybe we'll take smaller numbers to manipulate the equation. So when looking at x's, y's, and z's, the z's I probably wouldn't want to choose because, like in this case, in order to try to get rid of the 5, I would probably need to multiply this equation by 15, which would make my numbers really large and would make it a little more difficult to handle just because the numbers will be larger. So in looking at this, I think my y's would be the best choice. So what we're going to do is we're going to add 2 times equation, that should be 3, to equation 1 in order to eliminate y. So multiply this equation times 2. I would get 12x minus 2y plus 8z equals negative 6. Then I'm going to add that to equation 1. So equation 1 is here, and that's 4x plus 2y plus 3z equals 12. When I add them together, I get 16x, my y's cancel, and plus 11z equals 6. My next step now will be in creating another equation of 2 variables, and I have to cancel the same variable, meaning I have to cancel y's. So I can't, just say, oh, well, let's cancel a different number or different variable, because it wouldn't really work out. So let's take equation 3, and we're going to add negative 3 times equation 3 to equation 2. So if you look at your y's, what does the y have to be in order to make the y's cancel? So it would be negative 3, and this needs to be a plus 3 in order for it to go away. So in order to do that, we multiply this equation by a negative 3. And so we get negative 18x minus 3y, well, that's plus 3y, minus 12z equals a positive 9. Now we're going to add that to equation 2 here. So we will add 2x minus 3y plus 5z equals negative 7. We add those together, we get negative 16x, the y's cancel, negative 7z equals 2. So now we're done with step 1. So we need to do step 3. I rewrote the equation from our previous slide here and wrote it here. We need to solve the linear system for both of its variables, meaning we have to solve for our x and our z. And what's nice is that in this case, our x's already are able to cancel out. We don't have to manipulate our problem. There will be cases where you do eliminate a variable in step 1, but we'll have to manipulate the problem in order for it to eliminate. So the x's cancel, and I get 4. Ooh, what is going on? Let's see. Oh, there we go. Now we'll get 4z equals 8. And so therefore z equals 2. Now in order to solve for x, we take this 2 and plug it back into one of these equations. So I'll just pick the top equation. 16 times x plus 11 times 2 equals 6. So that's 16x plus 22 equals 6. Subtract 22 from both sides. And so I get 16x equals a negative 16. So therefore, my x will equal negative 1. Now that I have my z and my x, I can go on to step 3. I'm going to substitute these values into one of the original equations in order to solve for the final variable, my final variable y. If I go back here, I can see that I can plug it into one of these original equations. I will choose equation 3 just because the y is, there's no coefficient in front of it, so I'll just use that one. So if I write that, it is 6x minus y plus 4z equals negative 3. So if I go back, my z equals 2, and my x equals negative 1. So I'll plug it into this equation. 6 times negative 1 minus y plus 4 times 2 equals negative 3. So if I solve, negative 6 minus y plus 8 equals negative 3. Negative 6 plus 8 is 2, and then minus y equals negative 3. Subtract 2 from both sides. Y equals, well, negative y equals negative 5, which means my y equals 5. So how I write this is as an ordered triple. So my ordered triple is like the x, y, and z, the coordinates of the points. So my x is negative 1, y is 5, and z is 2. So we'll try another example in a different recording.